Hey everybody, so my name is Jesse Butler. I am an advocate with OCI, and I like to talk about cloud native things, Kubernetes, and other related things. And service mesh definitely falls in there. I've been playing with it quite a lot, so let's get into it. Okay, so let's just talk briefly about what a service mesh is, and then we'll get right into how we use them. I'm going to assume you understand Kubernetes, why we use containers, what microservices are. Let's not go down that road. But service mesh is a fairly new, within the last couple years, really the advent of this is happening. So this is an infrastructure component that lets us secure and observe and control services at scale within our cluster. Often we get a lot of benefits that we get from a lot of the day two services that we've crafted over the last 5 or 10 years without any service code changes, which is really critical. So a lot of options exist in this space. So Console, Aspen Mesh, who's our lanyard sponsor. But I'm just going to focus on two that are the sort of the bigger ones, Linkerd and Istio. So this is an infrastructure layer that allows us to monitor our service-to-service traffic. So typically, and in the case of Linkerd and Istio, deployed as a data plane and a control plane. So your data plane deploys alongside your applications in the form of a proxy, and your control plane allows you to configure that proxy. So this greatly reduces the complexity that we put into our services around things like traffic management, retries, circuit breakers. We get to kind of defer a lot of that to the mesh itself. We can also defer other things to the mesh, and that is kind of a slippery slope, which we'll also cover. So one thing I like to describe people coming new to this, what's the difference between an API gateway and a service mesh? They are different things. There are different levels in the architecture. So effectively, an API gateway is concerned with your north-south traffic, your traffic coming into your cluster. Service meshes are concerned with east-west traffic, the traffic between your services. So when you have two services behind an ingress, how they communicate is where the service mesh comes in. So the architecture, like I had said, we have a data plane that's deployed alongside the application, and that's done with this pattern called the sidecar pattern, sidecar container. What happens is that each pod that you want to add to the service mesh ends up getting a proxy instance injected into its pod. So that's the sidecar pattern. And effectively, anything that you add to the mesh with this proxy is able to be configured however we want. And the proxy gives us complete visibility into all the traffic on the wire between the services. So this is quite powerful. So this, in effect, and this is an example with Istio, Linkerd works exactly the same way. The gray boxes are pods. You have two services that are talking to each other. Maybe it's like an HTTP service, just doing like a GET. So with the sidecar proxy injection for the service mesh, we put a proxy instance in each pod that then actually fronts traffic for the service. The proxies talk to each other, and they do that according to the configuration we provide. And so, and that traffic can be like HTTP 1 or 2, it can be gRPC, really, that's a typo, it can be anything TCP based. And you can actually add MTLS or not, so you can actually lock down the entire mesh, which we'll get to in a minute. So what are some of the things that you get out of this? Because that's what everybody says, a service mesh, we're going to do this, we're going to use it, everybody's using it, why, right? Observability is one of the critical components that is addressed in the needs for like sort of your day two needs in a Kubernetes environment. So one of the things that we've learned, of course, running microservices at scale is observability becomes incredibly critical. And for years, 30, 40 years, observability, we know it's three things. So metrics, it's the aggregate data that shows like your system's performance over time and how it behaves. Tracing, which is like sort of the data about one instance of traversing your stack. And then logs, which give you specific breadcrumbs on the trail to sorting out what issues you're having, right? So these all three combine to give us this thing that we call observability. So the metrics are instrumented in scrape. So Prometheus is a really common utility here. So you modify your code, you put your metrics in, you deploy Prometheus, it scrapes your data, and then you can do with it what you need to actually aggregate that data into metrics. So the idea here is that this service path, this endpoint can service a customer's request usually in about 800 milliseconds, right? There's a metric, we have a baseline. So So that way, if you're humming along and all of a sudden you get something that takes 5.5 seconds, you can say, well, there's something wrong here. We need to analyze it. Traces are implemented on a per span basis. And these are things where, again, you instrument your code to say, okay, well, I am here. I am now leaving here, right? I am here with this data. I am here with that data in the code, so that when you see something, an anomaly in your metrics, you can dig in and say, well, what's happened here? Oh, I see. It took 5.5 seconds here. Let's dig in. Because I have traces through all of my services, I can say, oh, well, this usually takes 30 milliseconds here. It took 5 seconds. What happened? And then logs. These are very specific things that developers, we give these to our future selves as gifts, right? So we're triaging problems. Give yourself a little present, right? As you're writing the code and you're writing a piece of code that connects to something, could it fail? Could it fail because of a timeout? Could it fail because of credentials, right? Put those in your logs. Don't put in your log, did a thing and it succeeded. That's a waste of your energy. It's a waste of your future self's time, right? But the stuff that you want is like, how did this break and why? Because 6 months later, you're looking at it, that's where you look. You go into that trace, you say, oh, this service took 5 seconds. It usually takes 30 milliseconds. What happened? Let's go look at the logs. Oh, my connection to the data source timed out, 5 seconds. Now you know exactly what happened. So with Service Mesh, you actually get a lot of this stuff for free. You don't have to change your code. And with either Linkerd or Istio, you get free tracing at the boundaries. You get free metrics at the boundaries. So without any changes, you actually get a dashboard or API where you can get the data and a representation of exactly what's happening in your cluster at all times. So you get metrics and traces. You still add your logs, right? Istio and Linkerd aren't going to guess what your code's supposed to do, but it can tell you, this service went from here to here, called this service, it called that service, these are the latencies, these are the credentials, this is the information that was on the wire, this is the opcode, everything. I can tell you all of that for free, which is pretty amazing, because most of your issues in cloud are going to be triaged, at least at the base level, with that data. So you don't modify your code at all and you get it for free. Pretty powerful. So this is a representation of using some of that data. So this is taking some applications, deploying them in namespaces on Kubernetes, firing up the dashboard, and this is what you see. That's actually pretty amazing. Right off the bat, you can see here, if you actually click into these, you can see the traffic on the wire. That's aggregated here by service in your deployments. And in this deployment, you can actually see, like, wow, we have a success rate that's not 100%. What's going on there? And you literally just click through. And if you're a CLI person, Linkerd also has a CLI that allows you to see exactly that, which I find is really, really cool. Like, I live in the shell, so you can actually use the Linkerd CLIs to see exactly that type of data, and then you can pipe it off to things like egrep, right? So Kiali is the option for Istio to visualize all this stuff. So you actually get things like this really cool service graph that shows you all of the traffic. And again, if you had some faults, they would actually show up in red. If you have latency problems, yellow. So you actually get a visual indicator of exactly how things are running, all for free. None of the service code here is instrumented in any way. Now, if you have, like, say, a Prometheus metric you want to scrape that's a specific thing, of course, you're still going to instrument your code there. But at the boundaries, all for free. So speaking of, like, sort of the traffic in and around the services, let's talk about traffic management, because this is another huge use, right? So proxy instances provide all of the sort of traffic shifting and the traffic rules in the cluster. So you're fully aware of what all the traffic is. But you, as the DevOps person, the ops person owning that application, or the developer, you know how the application's meant to perform. So you can actually add your intelligence and your context to that application traffic management. So you can say, well, I know how this is supposed to behave, so this is how I want to route the traffic. Or maybe on a given day or with a given user, you want to say, well, let's actually modify that traffic flow and change it a little bit. So you're able to actually do that because you own the configuration for these proxies. It's very powerful. So let's look a little bit at traffic management with Istio. So this is an example of using the object types in Istio to set up a route where you're then able to get traffic to two different versions of the same service. So you have two deployments. You have what's called a virtual service, which is provided via a CRD from the Istio project. You can actually configure a virtual service attached to a destination rule, which is another Istio component, where you could say, well, here's the destination rules for V1 and V2, and we end up routing that traffic appropriately. So this all gets wrapped where you can actually deploy these things at the same time, and by default, you'll bounce between the two because Kubernetes will round robin between the deployments. But what you can actually do is you can route and then set weights based on the routes. So this is an example of a classic A/B test, right? So I've got version 1 and version 2. I'm going to throw 50% of the traffic to one, 50% of the traffic to the other. It's as simple as that. Now you can do this in Kubernetes, right? We all know how to do this, but this is the whole thing. That's kind of cool. And you can, of course, use this for other things too. So you have that pattern where you can manage all your traffic, where you can actually, enjoy a zero downtime deployment and modification of your versions and all that in any of these patterns. So canary deployments, blue-green, A/B testing, whatever you need to do, it's as simple as just crafting some YAML and throwing it out there using the tools you already know. So traffic mirroring is another thing. This is a real use case here where you use that same pattern, but you're actually able to throw 100% of your traffic still at your production versions, but then also take some amount of your traffic and mirror it to something else. So that's actually, it gives you something like a dark launch or like around feature flags where you can actually turn things on and off in production. You can actually deploy something in production and not give it production responsibility. But you can direct production, a copy of the production traffic to it, which is really very powerful as far as getting, so we move away from the idea that you need to record and replay with production data in order to really test, right? Or the flip side is, you can basically, you can modify any of the traffic flow based upon any of this filtering. So you can actually change what content users see based upon, say, their login ID. Because we see all of the data on the wire, you can actually look at, say, a request, find the user ID, or maybe you have your users grouped. Maybe there's a beta user group, and you can actually direct all the beta user group to the new version of the software, and then everybody else gets the old version. And you could do that on a potential test case sort of basis, which is really cool. So this gives you something where you're actually able to test in production responsibly and safely, right? Like everybody has been saying this for the last couple of years, especially, where we have, some people are spending a lot of money in the cloud. And it's like, well, you're not going to have like staging and prod and test and have them all the same size and shape. Which means fundamentally, especially your integration test, but even your functional test might not actually be a true representation of what things look like in prod. So you're actually able to, especially your services that mutate and talk to other data sources, right? You can actually use production traffic in production and test your stuff, because then you can redirect the downstream to test fixtures or other stubs, right? You can actually mock out the other endpoints, which is also very powerful. So there's a whole world of possibility here just around testing. Which brings us to actually testing our microservices, right? So this is fundamental to kind of resilience and getting quality software out is testing. So we have features that are built into the service mesh, whether it's Linkerd or your Istio, where you get retries, you get timeouts, you can implement a circuit breaker, all in the service mesh, okay? So that actually simplifies your code, like I had said before. But what you're doing is you're manipulating the on-wire traffic. So you make a request against something and you get an error back. It's not 200, whatever it is. Go through a list and say, in this case, do this, in this case, do that. You can actually have the service mesh do that. Maybe we retry 3 times. Maybe we retry and back off. Maybe we wait for 5 seconds, then retry. You can configure all of that and remove it from your code. But because of those features, you can also inject latency. You can inject faults, right? So you can actually deploy in an environment running Istio and fire faults or fire some percentage of faults at your services or inject random latencies. So you can do a little bit of chaos engineering for free, which is pretty cool. So, and I just actually talked about that. So enjoy this slide. And now we're done with it. So one thing about that is we're mutating data on the wire, and this is something that's going to start occurring to people more, I think, is you can abuse that, right? You can say, inadvertently change your wire protocol without any changes in your source code. So this becomes this really classic problem of configuration starting to mandate what your runtime looks like. And when you go to fix bugs in your source code, you can't find the problem, right? Because it's often your configuration and your service mesh. So watch out for modifying your on-wire data to the point where you're implementing functionality with it, right? Keep that in your source code, keep that in your services, or at least in comments in your source code, right? So that you can actually track these things. Because I see this as and a number of people see this as a potential slippery slope and sort of a space where we're going to have some pain down the road. And finally, security is sort of this last thing, and I say this a lot, like you get this for free, but it's really true, right? Security is one of these things that we tend to take for granted, and now people are realizing, well, I actually have to really pay attention to my container artifacts and what's going into my layers and how my Kubernetes secrets are managed. So we do a lot of work at the API gateway. We do a lot of work with our images, our at-rest data. We do image scanning. We monitor for CVEs. But what happens when you're through the API gateway and into the cluster? I mean, typically, it's just the Wild West, right? Because it's you. You own your services, and your services are talking to it. Unless you have a bad actor that infiltrates your cluster, and then you're in trouble. And so with security, both Istio and Linkerd use MTLS literally at the flip of a switch. Your service mesh can be turned immediately into a zero-touch, zero-trust network. So basically, nobody trusts anybody anymore. We have a certificate authority integrated as in the control plane, in the control plane. It actually manages the certificates for you, so you can actually do auth all transparently, and no longer will foo trust bar simply because it's in your cluster. Very powerful, and that's just literally you can just turn it on. So I think I'm out of time, but with that, I'll be around, and a number of us will be around for the rest of the conference. And if you have any questions or any comments or any corrections, let me know. Otherwise, thanks for taking the time, and see you. Enjoy the rest of the conference.